So in this particular video, we'll take a look at triangle similarity. And there are three ways that triangles can be similar, and we don't want to overthink these things. It's all in what's marked. Um, angle, or what we'll abbreviate as AA, A being for angle. What you're looking for are two angles in each triangle. So for example, if we mark this one as 100, so we have one angle in each is 100, and then if I put 20 degrees there, then we have an angle in each, or two angles that are congruent to each other in each triangle. So these two triangles are similar by angle, angle. Side, angle, side. It is set up exactly the way you need it. You need a side, an angle, and a side. So let's say we mark this one as 10. We'll just put a marking there and then 8. What we need, if we remember back to yesterday, similar figures, there were two things that we needed if we look up top here. We needed congruent angles, which we've seen so far today, and then we need proportional sides. So the sides don't have to be equal, they just have to all be in the same proportion to each other. So for example, since we have 10 and 8 on this particular triangle, very simple proportion there. If we cut them both in half to 5 and 4, we currently have two sides that match up. We need to make sure that this angle between them. So you can see we have a side, an angle, and then a side. And it's the same exact order in the bottom triangle. So for side, 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 we want all three sides to be proportional. So let's say we went 24, 18, and 12 in the bigger triangle. If I divide all three sides by 6, maybe, we'll do 4, 3, and 2. As we can see, so the scale factor there to make this similar by side, side, side would be 6. So a few examples right here. So state which similarity theorem we can use to prove each triangle, to prove the pairs of triangles are congruent. And so right here we see we have a side mark there. There's a 90-degree angle. We have a side here. So it looks like SAS, but what we need to do is just let's make sure very quickly that the sides are in fact proportional. So very quickly, 6 matches up with 12. So 6 over 12. Check to make sure. Does that equal 8 over 16? And sure enough, both of those simplify to be 1/2. So they are equal, which means these two things are similar by SAS because it was a side, an angle, and a side. We look at number 2. There are no sides marked. So what we should know right away is SSS, that's out because we don't have any sides marked. SAS, that's out because there are no sides marked. The only thing marked are angles. And if I put an A next to each one of those angles, right, that box being a 90-degree angle, I have AA in the top triangle. Well, sure enough, if we trace over this one in blue, we have the same exact angle in the smaller triangle. So those two angles match up, and they both have a 90. So in this one, these are similar by angle, angle. Number 3, quick heads up in case you've forgotten. This line, this upside down T means perpendicular. And what that means is we're going to be given basically 90-degree angles. So where MX touches AB, we get right angles, and that has that upside down T look to it again. What that tells us, we have right angles right where those two meet. And so if we look at the two triangles, they both have a 90, right? So there's the red triangle. If we take a look at the blue triangle, they both have a 90. There's one angle, and they both have a 58. We have no sides marked, so these are similar by angle, angle. Number 4, a little bit tricky. I'm going to go ahead and label some points on here. And what we can see, there's actually two triangles in here. You got the smaller one, ABC, at the top, and then if we look, the overall shape is another triangle. Well, right away we can see we've got some sides marked. So SSS and SAS are both in play. However, uh, we, we have to be careful because we need to figure out, do we have an angle, do we have another side? Well, currently we don't know the bottom part to either one of these. So that means that side, 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 it's out. It can't be side, side, side. So what we need to take a look at then is, can we get an angle out of this? So very quickly, if I were to write what's called a similarity statement, triangle ABC, what does it match up with in the big red triangle? Well, if we look carefully, right, ABC, A goes down to B, there's that line, and then over to C. So if we follow that same pattern in the red triangle, we start at A, we go down to D, and then over to E. Right? So the order here is important. And it also sheds a little bit of light on this because both of these triangles, if you notice, have an A. Or in other words, if you look at the top of the blue triangle, there's angle A. Well, it just so happens that the red triangle also has that very same angle, right? That angle A in the blue triangle can't be smaller than it is in the red triangle because it's the same angle they're using. So what we should see here, and if we check, right, so you got side, then an angle, then a side, and this one right here. So the trick with this one is to see there are two triangles, and two is to see up there at angle A, they actually both have an A in their names over here. And if we look at the picture, they both share that angle, so that's the congruent angle that they both have. Number 5, it's very, very similar again. We have kind of the two triangles that are in here, LUV and LMN. So very quickly, this particular blank would like us to name the triangle that matches up with LMN. So LMN being the red one. Let's follow the same pattern. And if you look, that should be LUV. And we're going to go ahead and say which one this matches up with. Again, this side's not marked, but the other two sides are. For side, 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 we have to have all 3 sides. We don't have that. So since that's not marked, side, side, side is out. Here again, we have this situation where they both have an L, don't they? We have LMN, LUV. They both have the L, and sure enough, they share it right down there. The red one and the blue one have the same exact angle. Here's a good chance we check it really quickly in terms of the proportion. I didn't do that in number 4, but 8 matches up with 40. We're going to check to see, does that equal 5 over 25? Should be able to simplify these pretty quick. Divide both by 8, you end up with 1/5. Divide both by 5, 1/5. So they are equal, which means these two things, we have a side in 8, the angle, and then we have a side in 5. So we have a side, an angle, followed by another side. So these two things are similar by SAS. And then one more example, something we can bring with us to the table is vertical angles. And if we notice STU, so if you follow that out, S to T to U, when we finish the triangle. So STU starts off down the 40 side. Well, here is a great chance to remind you that order matters in these statements. So we can't just pick whichever 3 letters we'd like in whatever order. We'll start with S again. But back to what I was saying before, STU, they went down the 40 first. In other words, that's the shorter side out of the 2 that are marked. So what's the shorter side in the top triangle? Out of 26 and 29, it will be the 26. So we'll go from S to K to L. And here again, if you look closely, 42 is a side. Then we mark the vertical angle, and then 40 is another side. So here's another example of SAS.